so we are going to be talking today about finding the slope of a function from the table and from the graph. Okay, so we're going to start with tables here. And slope, another phrase that you will see used for slope pretty often is rate of change. So we were finding a unit rate for everything that we did in 4.2. And those unit rates were rates of change. But for a unit rate, it is just a straight, I can just divide, I've got 600 miles divided by 4 hours. That gives me my speed in miles per hour. I was just dividing, right? The rate of change sometimes will be like that, but is not always, okay? The rate of change, the way we're going to find the rate of change or the slope is we're going to look in the change in our y value divided by our change in our x value. And I'm going to write this over here on the side. Have you guys seen that triangle before? Yeah. Okay. What do we call it in math? What's its special name? Or it's a letter. It's a Greek letter. What is it? I was just wondering if you heard it. It's a delta. So delta y over delta x. And delta, whenever you see it written in math, typically means change in. Okay, so whenever you see it written in math, it typically means change in. Velocity is going to be your change in distance over your change in time, so there's a good chance you have seen that with a formula for velocity. Yes, and we're actually going to look at a velocity. Actually, we're going to look at an acceleration example in a little bit. So, we are going to be looking at, we want to be looking at tables where we have what is called, right here, you may want to underline this, a constant rate of change. If we have a linear graph, then we will have a constant rate of change. Okay? So, I, on these first couple, am going to graph these on Desmos just for us to look at them to see what's happening here. So, if I add a table, just so you guys can see, 0, 1, 2, 3, 3, 5, 7, 9. All right, so if I graph these, do those look like a line? Yes. So if you graph them and they look like a line, you probably have a constant rate of change. But I'm not going to let you use the calculator or Desmos on everything for this test. You will probably have a calculator inactive section, and then you'll have a small calculator active section that have some of those like application problems where the numbers are kind of messy. Like homework that you guys did Friday, you guys could use calculators because I didn't expect you to be able to divide all of that stuff, by hand. But a lot of these are going to be whole numbers, so we're not going to use the calculator. So whenever we're looking to see if something has a constant rate of change, what we can do is we can look at the change in y over the change in x for each little interval, right? So if I look right here to go from 3 to 5, right? My f of x, remember that's my that's like my y, right? So if you want, sometimes in the table it will be called a y. So what is the change from 3 to 5? 2. Is it up 2 or down 2? Up 2. So it's a positive 2. All right. That is my change in y. And then I also need to look at my change in x from 0 to 1. What's that? Plus 1. So positive 2 over positive 1, that just gives me 2. All right, to check to see if this is a constant rate of change, I need to check the other increments as well. So from 5 to 7, what's that?
2.
Plus 2. From 7 to 9, plus 2. Over here, we're just going up by 1 each time here as well. So for each one of these, you're going to be doing 2 divided by 1. 2 divided by 1. Make sure you're doing change in y, which is over here with the y column, divided by change in x. Don't switch those because you'll have it wrong. So the rate of change is the same for every increment here. So that rate of change in this case would be 2. Okay. Questions? All right, let's look at the next table. If we think about that last one, it was pretty easy to see because we were just going up by 2 each time. And we were going up by 1 each time here, so we could kind of see the pattern. It was really simple. This one, it's a little more scattered this time. 2, 3, 5, 6. What happened right here?
It's going up by 2.
Okay. I went up by 2 right there, which is a little bit different. It's not going up by 1 each time, so this might be a little different. And just because I want you to know what the graph looks like also, let's graph this one too real quick. We won't always do this, but 2, 3, 5, 6, 9, 5, 1, negative 3. All right. Does that look like a perfect line?
No.
Well, it's kind of close, but that point right there looks like it's a little off, doesn't it? Well, yeah. I don't think this is going to make a perfect straight line. I don't think this is going to be a constant rate of change, right, just by looking at that graph. But let's see how we can tell from the table, right? So from 5 to 9, minus 4, okay? Over here from 2 to 3, plus 1. So my change in y over my change in x for that first increment right there is negative 4 over 1, which will give me negative 4. Okay? Caitlin, from 5 to 1, what happens there? Minus 4 again. But Caitlin, from 3 to 5, I'm adding 2. So if I do change in y over change in x, for this one, I'm going to get negative 4 divided by 2, which is negative 2. Are those the same? No. So the rate is not constant here. So you can't find the rate of change if you don't have a constant rate of change for these. So if you see one that does not have a constant rate of change, you won't have an answer. The answer will be that it's not constant. All right. So, for the next one. If I look from 6 to 15, what has happened there? Okay? All right, and from negative 2 to 0, add 2. So my change in y over change in x, I think I meant for this to be constant. It's not going to be. My change in y over change in x is going to be 9 over 2. So you could say 4.5, or you could just leave it 9 over 2. It doesn't matter there. A lot of times, as we learn more about slope, we might want a fraction instead of decimal, but 9 divided by 2. All right, from 15 to 26, Ian, how much does that go up? Are you sure? All right, 26 minus 15 is going to give us 11. So it goes up by 11, but how much do we go up by over here? Still 2, right? So are we going to get the same number here? We are not. So this is, again, the rate is not constant. Hello? Yes. You're welcome. Riley, you are leaving. And I'll keep recording so that will be posted. Okay. I really meant for that to be constant, but I obviously also had a little trouble with 9s and 11s there. Thought that first one was 11. Okay. But that one is not constant. Okay, let's go to another one. Oh, it's going to be not constant again, maybe. One of these is constant, I'm pretty sure. All right. So we have from -5 to -1. So Eddie, from -5 to -1, how much does that go up? 4. So that's up 4. What about from 0 to 2? 2. All right, so I'm getting change in y over change in x would be 4 over 2, which is just 2, right? All right, so the next one, comma from -1 to 5, how much does that go up? It's not 4. It's 6, since that's a -1. So it goes up 6, comma from 2 to 5. It goes up 3. All right, so my change in y over change in x looks different. I got to do 6 divided by 3, but what is 6 divided by 3? 2. So is the rate of change still constant?
Yeah.
Even though I got different numbers, right? Because they divide to still give me 2. And then if I check the last, from 5 to 15, Lexi, how much does that go up? 10. And from 5 to 10, Lexi? 5. Is that going to give me the same rate of change? There. I'll have change in y, which is over here on the right-hand side. That's 10 divided by 5. That is going to give me 2 as well. So 2 would be my answer here. Even though the numbers I'm dividing are different, I still end up with a constant rate of change. And let's think about what this looks like on the graph real quick, too. 0, 2, 5, 10, -5, -1, 5, 15. So if I look at those points, I don't have even increments, but do they all line up to make a straight line? They do, right? So that's what we're seeing. We have a constant rate of change. Okay, try example 5 on your own. Check with your neighbor, see if you think there's a constant rate of change. See if they've got the same thing as you. You can either check with these guys or those behind you. Okay, how many of you think that there is a constant rate of change to be found? Raise your hand if you think there is a constant rate of change. Okay? Alright, so those of you that think there is not a constant rate of change. Okay, so I've got some just not voters. Alright, so let's check and see if you guys have it. So this goes down 3. This goes up 3. So that'd be negative 3 divided by 3, which will give you negative 1. Right here you go down 2, up 2. So that'd be negative 2 divided by 2, which is negative 1. Here we go down 1, up 1. So that would be negative 1 divided by 1, which is, again, negative 1, right? So this one does have a constant rate of change. You should have gotten negative 1 for that rate. Okay, questions? All right, let's look at this in context of a real situation, okay? A somewhat real situation. A lot of times whenever you are looking at things like the number of customers coming through a store, do the number of customers coming through a store, is it always like the exact same every hour of the day? Probably not, right? You might be busier at times and slower at times, but because we are doing linear graphs right here, I need you to have perfect numbers right now. So we'll talk about what we will do if the numbers aren't perfect soon, but we're just not there yet. So find the rate of change for the following situation. Describe what your answer means in context of the situation. Did this one ask if we have a constant rate of change? It did not. It's basically assuming that there is a constant rate of change. Say that again. You're right, I do have that one wrong. Let me fix it. Let's do 130, 20. Yeah. There we go. All right. Fix that on yours. Change that to 120. Okay. So this one doesn't really ask us if it's a constant rate of change. I had a mistake on it, but because it's the first time I have used these particular notes. But we need to answer this in terms of the situation. So whenever I ask you to do this, I want your answer to be a sentence. Okay? It must be a sentence. All right? So when I'm doing rate of change here, if I'm concerned that there's a mistake, I can check everything. But really all I've got to do is look at my change in my Y. If it's given as a table that's horizontal, assume the X is the top line, Y is the bottom line. It's possible they might do it differently, but the EOC is almost, I mean, I've never seen an EOC problem where they tried to trick you up by switching which one was there, and I'm not going to do that either. So you can basically assume your X is your top line and your Y is your bottom line. So from 0 to 24, Blakeland, how much does that go up? Okay, and from 0 to 1, Blakeland, how much does that go up? Okay? 1. All right. So, in this particular case, I've got my change in Y over my change in X is 24 over 1. So I'm getting 24 as my answer. 24 what? What does that tell us?
It's 24 customers
24 customers per hour. Sometimes you might be a little confused about what goes where for your units, but your Y, how was your Y measured? Like what was it counting? Number of customers, right? So this top number, that 24, that was customers. Right, so if I just include customers with my 24, the X, my change in X on the top, how was that X being measured? Hours. So this can help us sometimes. This is not the most confusing situation. We'll see one that is confusing on the next one. This is customers per hour, right? Because customers is on top, hours is on bottom. So 24 customers per hour. So I said your answer needs to be a sentence for this because it says describe what your answer means in context of the situation. So who can tell me a sentence for this? Evan?
24 customers come in every hour.
Okay, so I'm going to say in a store, 24 customers come in every hour. Can somebody else say that a different way? What do you think, Isabella?
24 customers come in a store every hour.
Yes, but that one's really similar, so I'm not going to write it.
For every hour, there's 24 customers.
Okay, so we could say for every hour, there are 24 customers. That's another way. You don't have to write all of these. I just wanted to give you a variety so you can see different ways of writing this. Could somebody give me one more? One thing you can pretty much always do is just talk about the rate. So you could say customers enter the store at a rate of 24 customers per hour. Okay, so that is a possibility as well. These are all possibilities. You don't have to give all of them, but I do want to, you won't have many. I think there's maybe like 6, but I do want to see sentences for those few that are like application problems. Okay? Okay. All right, hopefully I've done this one right. I think it looks better than my other one. Okay. All right, so we're looking for rate of change. Same thing, describe it within context of the situation. So, Aiden, what would I do for this problem? Okay, good. And then adding 2. So my change in Y over my change in X. What would the change in Y be, Aiden? No. Top line is X, bottom line is Y. 4 over 2. What's it mean? All right, we're going to get 2. That's going to be our answer. 2 what? Nope. Ugh. This one's way harder than the last one, right? All right, so this one's super tricky. I wanted to give you a difficult one. How is velocity measured?
I forgot.
It's written right there. Feet per second. Okay? Feet per second. Velocity is measured in feet per second. So we've got 4 feet per second. What's 2 measured in? Seconds. Okay? So when we get the answer of 2, there are a couple ways we can write our units. One way we can write our units is we can say feet per second per second. Feet per second per second. It's just the top unit divided by the bottom unit. Same as the last one. It was just so much easier on the last one, right? Because the last one was just customers divided by hours, right? So it was customers per hour. This one, our top is feet per second. Our bottom is seconds. So it's feet per second per second. Okay? Does anybody know what is measured in feet per second per second? What do we call that? It's not velocity. It's not going to be our miles per hour because miles per hour is just like different units. You're using miles instead of feet, hours instead of seconds. Okay? This is called acceleration. Okay? Feet per second per second. It's how, so like whenever you take off fast in a car, you might be going, you're going 0 miles per hour, then you might be going 10, and then 25, and then 60, right? So it's how fast your speed is increasing every, second in this case. So you can see what's happening here is this, let's say it's a car. Its velocity was only 40 feet per second here, but its velocity has increased here, so it is accelerating. It's going faster than it was, right? So that's acceleration, feet per second per second. Okay, this shows up a lot in like some physics sort of context. But it's just whatever you're measuring the top end divided by whatever you're measuring the bottom end. Okay? All right. Now, let's look at graphs. Okay? It is still true that the slope is still your rate of change. It is still change in y over change in x. But I'm going to give you a couple other things to help you. All right, y, whenever you're looking on the graph, the y-axis, is it vertical or is it horizontal? It's vertical, right? So this is your vertical change over your horizontal change. And then there's something that teachers have been saying, algebra teachers have been saying for forever, it seems. A lot of teachers call this rise over run. Because if you're going to rise, that's going up or down, right? Really up. Rise really just means up. But for our purposes, up or down, right? Run is this way, left or right. Okay? Okay? The Y's, the vertical change, goes on top. Alright, so let's look at how this will work from a graph. The first thing you need from a graph to be able to find the slope is you need to find some points on this graph where the line crosses perfectly at the grid lines. Because if we're having to, you can estimate it if you don't have any of those points, but it'd be better if we don't have to estimate, right? It'd be better if we can find exact points where we know this point is 2, 7, or this point is -1, -4, right? So exact points on the graph. So looking at this graph, can somebody give me a point that they see that is on the graph? Raise your hand if you got a point for me. Lanaya? 3, 5. I think you're right there. That point right there looks great. Okay? Somebody raise your hand if you can give me another point that you think is exactly on the graph. All right, Evan?
4, 8.
All right, 4, 8. Okay, I think that looks good. Now, these are not the only two. For right now, I'm just going to look at these two, though. Okay? I've got 2 points. They're perfectly on the graph. If I want to go from one of these points to the other point, okay, I need to pick one of the points to start at. It does not matter which one I pick. Let's see. Giancarlo, do you want to pick the top point or the bottom point? All right, I'm picking the top point only because Giancarlo told me to pick the top point. It does not matter which one you pick, right? So if I start right here at this top point, and I want to go to the bottom point, I must go up or down first, right? So in this case, I've got to go down. How far do I have to go down, Giancarlo? -3. I've got my vertical change, my change in Y. It is -3. Okay? Then, I've got to go left or right. Okay, top number is always up or down. Bottom number is left or right because it's changing X. So I've got to go to the left 1. That's going to be -1 there because left is going to be your negative direction when you're going left to right. So I've got -3 over -1. Okay, -3 divided by -1 gives me a +3. There's my slope. Yeah, you just, that's basically all I'm doing right here. Counting down 1, 2, 3, and then to the right 1. Okay? All right, now, I didn't have to use these points. Okay? Let's say that instead, I think right here at -4 and 0, -4, that looks like it's on the graph, right? Let's say for whatever reason I decided I was going to use these 2 points. These 2 points right here. I still can do the same thing. Also, let's say I pick the bottom point instead of the top point. So I'm starting right here at this bottom point. So I would have to go up this far. 1, 2, 3, 4, 5, 6, 7, 8, 9. Up 9. So my change in Y would be up 9. And I need to go to the right this far, which is 1, 2, 3. Is that positive or -3? Positive 3. So my change in X for this one would be +3. What is 9 divided by 3? It is 3. So it should not matter which 2 points you pick on the graph as long as you have picked points that are actually on grid lines and you count correctly, you should get the same answer. All right. Okay, questions here? You guys remember doing this in 8th grade some? Okay. All right, so let's look at a few more. Make sure we've got it. All right, Ian, can you give me a point that is on grid lines there? Any point on grid lines is fine. -4, 0 looks good right there. And Haley, can you give me another point that is on grid lines? What? All right. What are the coordinates of that point? We got no coordinates. Nope. All right. So look at your x-axis right here. If you count over 1, 2, 3, 4 on that x-axis, that lines up with that point right there. So the x-coordinate right there would be 4. And then the y-coordinate, if you count 1, 2, 3, 4, -4. Right? So 4, -4. All right, so if I want to count this, Eddie, do you want to start at the top point or the bottom point? Top. All right, so if we start at this top point, we got to go up or down first. All right, we're going to go up or down, Eddie? Down. How far? 4. So we got -4. That is our change in Y. That's -4. Now we got to do our change in X. So now I need to go to the right. How far have I got to go there? 8. So I'll have right 8. So right 8. If I do -4 divided by 8, what will I get, Eddie? Nope.
-L.
4 smaller. So you really just have to reduce this, right? So if we reduce it, what will we get, Eddie? What can you divide both of those by?
1/2.
Yes, 1/2. So we get negative 1/2. And that'll be our slope. I will tell you, if you pick points that are closer to each other, it does make it a little bit easier to count your slope. You don't have to reduce. So like if I had picked instead this point right here that was really, really close, I would just go down 1 to the right 2, and I'd have a slope of negative 1/2, like right off. I wouldn't have to reduce anything. So the closer the points are to each other, the easier it is to count it. But you should get the same answer whether you pick them on the ends of the graph or really close to each other. You're doing negative divided by positive, so that will give you a negative there. All right, let's do this next one. All right, Savannah, can you give me a point on this graph? Negative 3.5. That looks great. Let's see, Anya, can you give me another point? Good. I like that. Simple one. All right. And let's see, Lexi, do you want to start at the top point or the bottom? Bottom. All right, so if we start at the bottom, will we go up or down? Gonna go up. How far? 5. So we go up 5. So that means our change in y on the top is going to be a positive 5. All right, then we got to go right or left, Lexi? Left. How far? 3. All right, and so is that going to be positive 3 or negative 3? Negative 3. So positive 5 over negative 3. Does that divide? Does it reduce? No. So a lot of times we want our slopes to be fractions anyway, so we're just going to say negative 5/3 here. Ooh, that's fun. There. The negative right here, you can put it in the top or the bottom, but it's most common to see it written out front right here. Okay, questions? All right, let's see if we can finish this up pretty quick. All right, the slope of the lines that decrease whenever you're going from left to right, what can we say? It's going to be negative every time. So if you have a decreasing line as you go from left to right, it needs to have a negative slope. If you do not get a negative slope, you've messed something up. Okay? The slope of lines that increase from left to right, so if we have an increasing line, that's going to have a positive slope. Okay? So these problems, I don't need you to tell me the answer, the actual slope. I just want to know whether or not they're positive or negative. All right? So let's see, Giancarlo, for number 11, is that line going to have a positive or a negative slope? Positive. As I start over here on the left-hand side and go to the right, I'm increasing, so it has a positive slope. Camel, what about the second one? That one's negative. And Eddie, what about the last one? That one's positive. So always check this. If you have a decreasing line, you should have a negative slope. If you have a increasing line, you should have a positive slope. All right. Vertical and horizontal lines. Okay? Undefined and 0. Which one's which? All right, let's do change in y over change in x. So I could pick a couple points. I'm going to pick these 2 points right here on this particular graph. All right? So change in y over change in x. So if I say start at this left-hand point, how much do I need to go up or down? 0. So 0 is on top. How much do I need to go left or right? I need to go to the right 4. Okay, so it'd be a positive 4. What is 0 divided by 4?
0.
It is 0. It's okay to have a 0 in the numerator of a fraction. The slope of a horizontal line is 0. Okay? Look at what happens if I try the same thing with a vertical line. Okay? Change in y over change in x. Let's say I start at that top point. How much do I need to go up or down? Down 2. That's negative 2. That goes in the top of the fraction. How much do I need to go left or right? 0. Can I divide something by 0? You cannot. Okay? You cannot divide by 0. So if you find yourself dividing by 0, that is called undefined. Another thing I always tell students is the slope of your line is the steepness of the line, right? So if you have a horizontal line, if you're thinking about going skiing, and you're trying to ski on something that's horizontal, how steep is that?
Not steep at all.
Not steep at all. Now, as your slope increases, your steepness gets higher, right? So if you have a slope of 4 versus a slope of 0, 4 is way steeper, right? If you have a slope of 7, that's even steeper. So if you go all the way to a vertical slope, that's maximum steepness, right? It is so steep that you can no longer even describe its steepness with a number. We just have to say it's undefined, right? So it's like a cliff right there. Undefined is for vertical. It is really easy to get these mixed up, right? Eddie remembered, because he's a little ahead of us, those 0 and undefined. But maybe got those mixed up. Yeah. But it's really easy to get them mixed up, so be careful with them, okay? All right. Okay. Couple application problems, and I'm going to let you guys get started. All right. So, rate of change. Okay. Here we have 2 points. Caitlin, you want to use the top point or the bottom point? Okay, bottom. And should our answer be positive or negative? Positive. All right, so I'm going to go up this far. How far did I go up? 3. So my change in y over change in x, it's positive 3. And what am I measuring that y in? What are the units for my y-axis? Gallons, right? Amount in gallons. So I'm going to say 3 gallons. All right. Then I need to go to the right 4. And so if I go to the right 4, it is 4 minutes. In the case of, we could leave this a fraction. We could say 3/4 gallons per minute. Or in the case of application problems, a lot of times you want to get decimal, so set 0.75 gallons per minute. There. Now, be careful with this. For these, I want you to write me a sentence. So in this case, we're talking about a leaking tank. We would say water leaks out of the tank at a rate of 0.75 gallons per minute. And I just made up that it was water. It doesn't specifically tell me water. You can use some poetic license. If you do 3/4, that's fine also. Either one's fine. The units are especially important. Make sure you have those, okay? All right, last one. This one's tricky. So super tricky. All right. So we need some points where we cross perfectly at grid lines. And there, I think they are going to be, ooh. Yeah, I think just the endpoints is probably the best. It might.
I see one that was directly on the line.
It's half a year.
It's not the one.
Yeah, I can't really tell. I don't think this one right here is exact. This one might be the point that's exact.
I don't think
What do we think?
The one below it.
We have to make it. I think this might go just a little above. I think it's going to be this one, don't you? Let's go with that one.
I hate problems like these where you can't tell.
Okay. I try to make sure, at least on quizzes and tests, that I've used one that's a little more clear. All right, so we need to do change in Y over change in X. Should our answer be positive or negative for this? Negative. Okay? All right, so let's say we start at the top point. I've got to go down. Okay? It's not 10.
Oh.
It's not 10 because look at my scale over here. Is each one of those blocks just one?
Oh.
It is not. Now, on the last problem, it was, so we didn't have to worry about that. But on this one, it's not. So I'm actually going down. They're going up by each little block right here is 100, right? So if I go down 10 blocks and each one of them is 100, I've actually gone down 1,000. Yeah. Okay. Then I've got to go to the right. How far?
9.
Is it really 9?
No.
Oh, right here. This was like half a year. And then we went over to 5 years. So 4.5. And so this was negative $1,000 in 4.5 years. And the application problems, I will let you use a calculator for. So if you take 1,000.
22.2 repeating.
All right, so we got 222.2 repeating dollars per year. So let's write a sentence for this. What does this tell us?
A laptop goes down 222.2 hours per year.
Let's not say the laptop. What are we talking about the laptop? The value. I like the word value a little better than price of the laptop. And I didn't put the negative. I should have. That negative, it tells us it's decreasing, right? The value of the laptop decreases 222 point. I'm gonna go $222.22 per year. If you do the point repeating, that's fine also. Now, notice I did not put negative right here. What takes care of the negative?
The money. The decreasing.
This word decreasing, right? That tells me it's negative, so I don't have to use the actual negative. In fact, I don't want to because it would be wrong. Okay. All right. So we did not get through this quite as quickly as I was hoping. So and got. Alright, so, let's see what I want you to do.
Oh, dang it, I lost my paper once again.
Let's do the first page. Okay? So, first page, number 1 through 6. So that first page, front and back, is all I want you to do. You do not have to do the last 2 pages, but don't lose them. We are going to use them at the beginning of class tomorrow. Okay? All right, you got about 5 minutes, so try at least one. And I meant for these to be constant rates of change for these, so you shouldn't have to check them, but there's a chance I made a mistake because I also made this worksheet today as well. So If you find mistakes, let me know.